Hello, Algebra 2. So in the last lesson, we talked about circles, and with circles, we could find a center. It was the H and the K. Both of those are the opposite of what you see. And then we were able to find the radius, and we were able to draw circles pretty easily. We also went through the process of completing the square so that we could come up with the equation in standard form. Well, today we're going to talk about the ellipse. And looking at this first piece of paper can kind of get a little overwhelming because it looks like there's a lot to talk about. But I'm going to try to break this down and make it as easy as possible because the ellipse is kind of similar in some ways to the circle, and we'll talk about that. So there's going to be two kinds of ellipses. Ellipses is the plural form of the word ellipse. There is the ellipse that is a horizontal ellipse, which simply means that it is wider going left to right than it is tall going up and down. So a horizontal ellipse is going to be elongated horizontally. We also have the vertical ellipse, which you can see down here, which just means that it is going to be taller going up and down than it is wide going left and right. So that's the difference between those. Kind of makes sense. Just think about what the word horizontal and what the word vertical means, and that will make sense. Now we still have the center. So the center is going to be something that we're still focusing on, the center of the ellipse. Right now, we're just focusing on what happens if your center is at the origin. We will, though, today talk about, what if it is some other place. But right now, we're just going to start with their being centered at the origin. All right, we have what we call vertices and covertices. But before I talk about that, let's talk about these over here. We have three variables. We have A, B, and C. A squared, and that comes from these denominators, right? A squared is always the larger one. B squared is always the smaller one. Now look at this one. This one says it's a horizontal ellipse, and the A squared is underneath the X. Well, because the X-axis goes left to right, and the A squared is bigger, then that makes sense that we're going to have a horizontal ellipse because it's going to be wide. Whereas if we look down here at the vertical ellipse, notice that the A squared is underneath the Y variable. And think about the Y-axis. It goes up and down. And if A squared is bigger, that's why this particular ellipse is going to be a vertical ellipse. It's going to be stretched in that direction. So your A squared, if it's under the X, it's going to make it wider. If your A squared is under the Y, it's going to make it taller. So that's how you know the difference between the horizontal ellipse and the vertical ellipse. So the A squared is always the larger denominator. The B squared is always the smaller denominator. So once you know the A and the B, we can find C. Now this is not the same thing as using the Pythagorean theorem. It is not the same formula at all. This one is A squared minus B squared equals C squared. Now let's talk about what A, B, and C actually represent. So when your A, we said the A is always bigger, right? So the A is going to represent the distance between the center of the circle and the vertices. The vertices are always going to be going whichever way your ellipse is. If it's horizontal, then your vertices are going left to right. If your ellipse is vertical, then your vertices are going up and down. So your vertices are farthest away from the center. Now B represents the distance from the center to what we call the co-vertex, or the plural form of that would be co-vertices. And remember, B is smaller. So for the horizontal ellipse, this right here would be the distance for B because I'm going from the center of the circle to the co-vertex. It's not going to be as far away from the center of the circle as the vertex. Over here for the vertical ellipse, my co-vertices are going to go left to right because that is the smaller distance. So what does C represent? C is the distance from the center to a focus. Now we talked about a focus when we had parabolas. Remember we said that in a parabola, your parabola always opens around the focus? Well, this almost looks, if you can kind of imagine it, it kind of looks like two parabolas, right? One that maybe has opened down and one that maybe has opened up. And so each of those is going to have a focus. So you have two of them, which we call foci. That's the plural form of the word focus. And the foci are always going to be going in the same direction as the vertices. So if your vertices are going left to right, then your foci are always going left to right. If your vertices are going up and down, then your foci are always going up and down. So just to reiterate real quick, A is the distance between the center and a vertex. B is the distance between the center and a co-vertex. C is the distance between the center and a focus. Now we also have what are called a major axis and a minor axis. Major means it's going to be longer than the minor axis. So here, your major axis would be horizontal because it's longer than going up and down. But for this one, your major axis would be vertical because it's longer than going left to right. So whichever one is the longest is your major axis, whichever one is the shortest is your minor axis. I know that's a lot of information, but I think once we get going on these, it's going to make a lot more sense and seem much easier than what this page kind of portrays it to be. So let's just jump right on in to example number 1. It says find the coordinates of the center, vertices, co-vertices, and foci, and then sketch the graph. Well, I already told you guys that we're starting off with the easy ones, the ones that are centered, and I'm writing the wrong word. I'm using the word center, but I wrote vertex, silly me. Center, we are going to start off with the ones that are centered at the origin. So right now our center is 0, 0. I'm just going to go ahead and plot that. I'm also going to go ahead and label my axes. All right, so looking at the equation, sorry, this is shaking so much, I'm moving a lot, I guess. We have x squared over 25 plus y squared over 9 equals 1. So remember we said that a squared is the larger number. So for us, that means that a squared is 25. Now let's find what a would be, and that just means that we have to square root both sides. And remember that a represents the distance between the center and the vertex, which means it can't be negative, right? You can't have a negative distance. So for this particular problem, a is going to be 5. All right, b squared is your smaller denominator. So b squared is going to be the denominator of 9. Again, I'm going to square root both sides. I'm going to find out that b is 3. Remember, that means the distance between the center and the co-vertices. Okay, so let's go back to a real quick. If my center is at 0, 0, and if it's underneath the x, that means that we have a horizontal ellipse. It's going to be wider. So according to what we just said, we said that a is 5. Remember, a represents the distance between the center and the vertices. So I'm going to go to the right 5, and I'm going to go to the left 5. And what that has just given us are the vertices. You can write it as 5, 0 and negative 5, 0. I'm going to write it as plus or minus 5, 0 so that I only have to write it one time. All right, we said B represents the distance between the center and the co-vertices. Again, the B is underneath the Y for this particular problem. So that means we're going to go up or down 3 spaces. So I'm going to go up 3 and I'm going to go down 3, which is going to give me the coordinates of the co-vertices. Again, if you want to write 0, 3 and 0, negative 3, you can. I'm just going to write 0, plus or minus 3 so that I only have to write it one time. So I have the center, I have the vertices, I have the co-vertices, but what I'm still missing are the foci, and that comes from finding C. So remember the formula. The formula was that C squared equals A squared minus B squared. Okay, well, we already knew that A squared was 25 and B squared was 9. So 25 minus 9 is 16, and if I square root both sides, that means that C is 4. So remember we said that C represents the distance between the center and the foci, And not only that, but it's going to go along the same axis as your vertices. Okay, well, our vertices came from the X. We went left and right 5. So I'm going to do the same thing for the foci. I'm going to go left and right 4. So for the foci, I'm going to write plus or minus 4, comma, 0. So we have everything we need to graph this ellipse. The only thing that I need to do now is go back and connect the vertices and the co-vertices together. Remember that your ellipse is going to open around your foci, so they're going to be inside of the ellipse. I did a terrible job right there, but that's okay. I'm going to keep going. But that's all you have to do for example number 1. So it all comes down to, can you find the A, the B, and the C, and can you determine which way they go? That's it. So let's look at example number 2. So we have x squared over 36 plus y squared over 81 equals 1. I'm going to start with the larger of the two denominators, which is 81. So a squared is 81, and that means that a is 9. All right. Then the b squared is the smaller denominator, which is 36. And so when I square root both sides, b is 6. Now I'm going to go to the formula. C squared equals a squared minus b squared. So we're going to have 81 minus 36, which I believe is 45. Bummer, that is not a perfect square. No big deal. We're going to square root both sides. Let's talk about 45. How would it break down? 45 would break down into 3 times 3 times 5. We have a pair of 3's, so 3 comes out and 5 stays underneath. So we have the A, the B, and the C. All right, let's talk about the center. We're starting with easy ones where our center is at 0, 0. All right, vertices. Vertices come from knowing what the A is, and that came from looking underneath the variable of y. So that means we're going to be going up and down this time. And so A is 9. So I'm going to go up 9 and down 9. So my vertices are 0, comma, plus or minus 9. All right, the co-vertices come from the B. The B was underneath the x variable. That means we're going to go left and right. And so since we found out that B was 6, we're going to go left 6 and right 6. So our co-vertices are going to be plus or minus 6, comma, 0. All right, now I need the foci. Okay, so remember foci, they're going to go the same direction that your vertices went. The vertices for us went up and down. So we need to go up and down 3 on the square root of 5. But let's talk about where that is, because what if we don't really know that number? Well, that came from having the square root of 45. Remember, we broke that down to get 3 on the square root of 5. So let's talk about the square root of 45. What are some perfect squares that it would be in between? Well, I know the square root of 36 is 6, and I know the square root of 49 is 7. So clearly this number is going to be somewhere in between 6 and 7, and it's going to be closer to the 7 because the 45 is closer to 49 than it is the 36. So I'm going to be going up and down over maybe 6.5, right? So 1, 2, 3, 4, 5, 6, and maybe a little bit more than 6.5, right? Because I'm closer to the 7, and then I'm going to do the same thing going down. 1, 2, 3, 4, 5, 6, and then closer to the 7. So how do I write that as an answer? Well, I'm just writing 0, comma, plus or minus 3 on the square root of 5. So it's totally okay if you don't get a perfect square. That's going to often happen. You just estimate about where it is. So you need to know your perfect squares so you can figure out what is it in between. And now we're just going to connect the co-vertices and the vertices together. And again, like I told you with the circles, I'm not expecting perfection. as long as your coordinates are in the right place. If it's not the most perfect ellipse, that is no big deal. All right, so far so good. Next one. So this one says the vertices of an ellipse are plus or minus 10, 0, and the foci are plus or minus 6, 0. Find the equation and sketch the graph. Okay, so vertices, remember, they come from knowing your value for A. So right now, here's what I know. That my vertices are here and here. So I have negative 10, 0. I have positive 10, 0. What point would be directly in the middle? You may have already guessed it, the origin. So what that tells me is that my value for A is a 10, because from the center, this problem went 10 to the left and 10 to the right. Now the foci are plus or minus 6, 0, so it went this way and this way. Remember, the foci are always on the same axis as the vertices, which so far is looking pretty good. The foci always also gives us our value for C. So according to this particular problem, because C represents the distance between the center and the focus, and it's 6 spaces away, so C is 6. So if I go to my equation, which is a squared minus b squared equals c squared, if I plug in what I know about A and C, that is going to help me find B. So 10 squared is 100, 6 squared is 36. I need to subtract the 100 over, so 36 minus 100 is negative 64. I then need to divide both sides by -1, so now I have b squared equals 64, and if I square root both sides, I'm going to get that b is 8. How is that useful? Well, remember, b represents the distance between the center and the co-vertices. Now the vertices have already gone left and right, so the co-vertices are going to go up and down. So I'm going to go up 8 and I'm going to go down 8. So here I can go ahead and actually finish the graph out with my horizontal ellipse. It's wider than it is tall, but it also asks us to find the equation. So we know that the formula is x squared over something plus y squared over something equals 1. We just need to figure out what the two somethings are. Well, because it opened wider to the left and to the right, that means that a squared needs to go right down here. We said a is 10, so a squared would be 10 squared, which is 100. We know that the co-vertices were going up and down, which means it needs to go underneath the variable y. So we're going to put b squared, which is 8 squared, and that number turns into 64. So here's our equation, and there's the graph. All right, example 4, we have an equation, but it doesn't look like the standard form. Now remember, the standard form that we have been looking at looks like this, right? Notice in both of these equations, they both are set equal to what? They're both set equal to 1. So in our problem, that's the issue, is that we don't have a 1 over here. How do I make 144 become a 1? Well, if I divide by 144, that's going to turn that into a 1. But if I do that over there, guess what? I have to do it on the other side all the way through as well. So I'm going to go through the equation and divide every term by 144. All right, 16 over 144 reduces because 16 goes into 144 9 times. So I'm left with x squared over 9. Same thing's going to happen here with the 9 and the 144. 9 divides into 144 16 times. So now I have y squared over 16. And on the right-hand side, I now have a 1. So there's our equation written in standard form. The a squared is always your largest one. So for us, a squared is 16. That means that a is 4. The b squared is the smaller one. So b squared is 9. That means b is 3. We're going to go back to the formula, which is c squared equals a squared minus b squared. So right now I have c squared equals 7. That means that c is the square root of 7. Now remember, what does that estimate to? What are some perfect squares that surround the square root of 7? Well, the square root of 4 is 2, and the square root of 9 is 3. So the square root of 7 is going to be somewhere in between 2 and 3. That's going to help us with finding coordinates for the foci. So let's get going here. According to this, I'm going to write over here now because I'm running out of room. The center, because again, we're starting with the easy ones, they're at 0, 0. I say easy like they're going to get harder. They're not really going to get harder. All right, then the vertices. That comes from knowing what A is. A is 4, and it's underneath the Y. So we're going to be going up 4 and down 4. So we have 0, plus or minus 4. The co-vertices comes from knowing what B is, which is 3, and that was under the X coordinate, or the X variable, so we're going to go left and right 3 spaces. So we have plus or minus 3, 0. Lastly, we need to know the coordinates for the foci. Remember, they're going to be going in the same direction as your vertices. So the vertices went up and down, so the foci are also going to go up and down. So we're going to be going up in somewhere in between 2 to 3 spaces, and we're going to go down somewhere in between 2 to 3 spaces. So we're going to have 0, plus or minus the square root of 7. So we have the center, vertices, co-vertices, foci, and as far as sketching the graph, now all I have to do is connect the vertices and the co-vertices, and we are done with example number 4. Hope everybody's doing pretty good so far. Okay, so now we have a change. Here we have what happens if it's no longer centered at the origin. It really doesn't make it harder, it's just a matter of identifying the H and the K. Now for the ellipse, well, just like for the circle, the H is always going to go with the X, the K is always going to go with the Y. The same thing is happening here. So example 5, we're not going to graph this one, but we're going to find the center, the vertices, the co-vertices, and the foci. And notice that right now it's not in standard form. So I need to make this 20 turn into a 1. So I'm going to divide by 20, but just like we did a couple of examples ago, that means that you got to divide everything by 20. So we're going to go all the way through and divide by 20. So I can reduce this. So I'm going to get x minus 2 squared over 4, because 5 over 20 turned into 1/4, plus y plus 3 squared over 5. Again, we just reduced. 4 over 20 turns into 1/5, and we're going to set that equal to 1. All right, so a squared is always larger, and so 5 is larger, so a squared is 5, which means that a is the square root of 5. B squared is your smaller denominator, so b squared is 4. That means that b is 2. Now I'm going to use the formula c squared equals a squared minus b squared, which means that c squared equals 1, which tells me that c also equals 1. So we have our values for a, for b, and for c. Okay, so let's start with the center. So we want to do h, k. Remember, that means the opposite of what you see. So for us, h is going to be a positive 2. K is going to be a negative 3. Remember, h and k, they're inside with the function. Remember, Hayavas means that that's going to be the opposite of what we see. Now, here is where you have to use your brain a little bit. And sometimes some people do better with this next part if they actually draw the picture, even if you're not asked to draw the picture. So if you feel like drawing a picture would help, we can do that. And I'm going to do that just because I'm a visual person. If you feel comfortable doing it without drawing a picture, that is okay as well. So here's what I mean. The center is at 2, negative 3. I'm just going to put C for center. All right, let's talk about the vertices. So according to what we've been learning about today, the vertices, we need to know the a. For us, a is the square root of 5, which is not a whole number. So let's talk about what the square root of 5 would be in between. Well, we know the square root of 4 is 2. The square root of 9 is 3. This is obviously closer to 2. So we're going to be going 2 and a little bit farther spaces away from the center. Well, which way are we going? Well, because this came from the a and the a squared was underneath the variable y, we're going to go up and down. So I'm going to go up and down. So up 2 and a little bit, and then I'm going to go down 2 and a little bit. Now, how does that look for actually writing the coordinates? If I'm going up and down, which part of this point is changing? The y is changing because I'm going up and down. That means the x is not changing. So the 2 is going to remain the same, but I'm going to take the -3, and I could be going up the square root of 5, or I could be going down the square root of 5. So I'm going to put plus or minus the square root of 5 with the y coordinate because I went up and down. Remember, y-axis goes up and down, so if I'm moving up and down, I'm going to change the y coordinate. Now let's talk about covertices. So covertices come from b. Our b is underneath the variable x, so we're going to be going to the left and to the right 2 spaces. So I'm going to go to the left 2 spaces. I'm going to go to the right 2 spaces. Now, because this is a whole number, we can actually figure out what that is. If I went over to the left 2 spaces, I now am at 0, -3. And if I go over to the right 2 spaces, I'm now at 4, 3. So look what happened. Because we moved to the left and to the right, we were taking the x coordinate of the center and we subtracted 2 and then we added 2 because we went left and right, and that changes your x coordinates. Lastly, we're going to figure out the foci. Remember, the foci are always going to go in the same direction as your vertices, and our vertices went up and down. So the foci are going to go up and down, but they're just going to go up and down by 1 space. So again, that's going to change your y coordinates because you're going up and down. Well, if I go up 1, -3 plus 1 is -2. And if I go down 1, -3 minus 1 is -4. Again, you can see that in the graph. So sometimes graphing for some people is easier. If you're comfortable with adding and subtracting and not having to draw a graph if not asked to, then that's okay as well. Okay, example 6. Here we go. We're going to do it all. We're going to come up with all the coordinates, and we're going to be graphing. So again, a squared, let's see if I can get this all in the video here. A squared is your larger denominator, which is 49. So a is 7. B squared is your smaller denominator, which is 25. So b is 5. I'm going to use the formula c squared equals a squared minus b squared. So 49 minus 25 is 24, which is not a perfect square. No big deal. 24 breaks down into 2 times 2 times 2 times 3. I have a pair of 2's, so I get to take out a 2, but I'm left with a 2 and a 3 underneath, which leaves me with a 6 underneath. So let's start by writing down what the center is. This is where we want to know h and k, which are the opposite of what we see. H is -3, k is +4. So I'm going to start by plotting that point. And I'm just going to put a C beside it for center. All right, let's figure out the vertices. Remember, they come from the A, and our A was underneath the variable x. X-axis goes left to right, so we will be going left to right. So I'm going to go left 7. So 1, 2, 3, 4, 5, 6, 7. And then I'm going to go right 7. 1, 2, 3, 4, 5, 6, 7. So let me go ahead and write those coordinates down. So I have -10, 4, and then I have 4, 4. Again, what happened? We went left and right. So we took the x coordinate of the center and we subtracted 7 and we added 7. All right, covertices come from B. Our B came from underneath the variable y. So we're going to be going up and down 5 spaces from the center. So I'm going to go up 5 and then I'm going to go down 5. So I have -3, 9 and -3, -1. Again, this time from the center, we just changed the y coordinate because we added 5 and we subtracted 5. The x coordinate did not change. All right, last thing we need are the coordinates for the foci. That's going to be going along the same as the vertices. Our vertices went left to right, so our foci will also go left to right. Now, we have 2 on the square root of 6, but remember what that came from. That came from the square root of 24. What are some perfect squares around that? Well, we know the square root of 16 is 4. We know the square root of 25 is 5. So we're in between 4 and 5, but we're really close to the 5. So from the center, I'm going to go left and right. 1, 2, 3, 4, almost 5. And now I'm going to go right. 1, 2, 3, 4, almost 5. Now, how do I write that down? Left to right changes your x coordinate. At the center, the x coordinate is -3. If I go left to right, I'm going to plus or minus 2 onto the square root of 6. I'm changing my x coordinate because we went left to right. The y coordinate does not change. Just the x coordinate changed. And now the last thing we're going to do, and the easiest part by far, is just connecting. I said the easiest part and then I missed a point, didn't I? I didn't hit it so well. Anyway, we're connecting the vertices and the covertices, and there you have your ellipse with all of the pertinent information. Okay, so example 7, kind of working backwards. We have a picture. We're going to come up with the equation. So one of the things that you want to immediately start off with is finding the value for your center. Where is the center? What are the coordinates? Well, in this particular picture, it is at -4, +3. So I now know the h and the k. Now, what else do I need to know? Well, I need to know the a. I need to know the b. Do I need to know the c? No, because the c is not anywhere in your formula, and all we're being asked to do is find the formula. So let's figure out the value for a. Remember, a represents the distance from the center to the vertices, and that's the longest distance. So for us, that's going to be going up and down. So our value for a is 5. Now, real quick, let's just talk for a second, because I haven't really talked about this yet, but this is useful information. This right here, remember I told you earlier, is the major axis. Remember, that's going to be the longer one. This one right here is the minor axis. So if you were asked to find the length of the major axis, for this problem, it would have been 10, right? Because it takes 10 spaces to get from this vertex to this vertex. All right, let's talk about finding B. That represents the distance between the center and the covertices. Well, if you look at the picture, you can see from left to right, they went 3 spaces from the center. So our value for B is 3. Again, that whole thing right there is called the minor axis, just throwing some vocabulary your way. So if you were asked, what is the length of the minor axis, you would have a length of 6 because it takes 6 units to get across from left to right. Okay, so now we need our equation. So I'm going to do x minus h. What's going to happen right there? We're going to turn that into a plus. So I have x plus 4 squared over something. I'll come back to that. Plus, then I'm going to do y minus k. So y minus 3 squared over something. I'll come back to that. Equals 1. All right, so the a squared is the bigger one. Now look at our ellipse. It was longer. That means it went up and down. So that's going to go underneath the y's. That's where the a squared needs to go. We already determined that a is 5, so 5 squared is 25. The b squared is going to go underneath the x because that was the shorter distance. So we already found out that b is 3. And so square that, turns it into a 9. And so that would be your answer for example number 7. All right, number 8, I'm going to go through this a little bit more quickly. I'm going to start off by writing the coordinates of the center, which would be 2, -5. So I have my h and my k. I need to figure out the a and the b. All right, this one's longer, so that's going to be the a. So it's going over 1, 2, 3, 4, 5, 6, 7, 8. So a is 8. Now it went left to right, so that tells me that it's going to go with the x's. B, it's going up and down, and it went 1, 2, 3, 4, 5. And up and down is going to go with the y's. So here we go. I'm going to do x minus 2 squared. I've already determined that the x is going to go with the a, so I'm going to put that over a squared, which is 64. Then I'm going to have y plus 5. Remember, I'm doing the opposite of what I see. Squared over, I've already determined that the y's go with the b, and so if b is 5, that's going to be over 25, and we're going to set that equal to 1. All right, we are almost done. So here at the end is just simply being able to take an equation and rewrite it into standard form and then do what we have been doing today. So this is again where you're going to be completing the square. So let's take a look. I'm going to start by putting the x's together. So I have 4x squared plus 24x. I'm going to leave a space. Then I have plus y squared minus 4y. Again, I'm going to leave a space. And then I'm going to take that constant of 36 and I'm going to move it over with subtraction, and that's going to turn it into a -36. Now, if you remember, when we learned to complete the square, you can't complete the square until your leading coefficient is a 1. And that is a problem for us because this is not a 1x squared, it's a 4x squared. So I'm going to take out a 4, turning that into x squared plus 6x. So real quick, all I did was I divided both of these things by 4 because I need my leading coefficient to be a 1 if I'm going to complete the square. Now I don't have that same problem back here with the y's, right? So I don't need to take anything out of that. All right, now let's figure out what we're going to put in a blank right here. So remember when we were completing the square, we're going to take half of b. So half of 6 is 3. Then we're going to square it. 3 squared is 9. Here's the part you have to pay attention to. I'm not simply going to put a plus 9 on the other side, and here's why. Because I have this 4 unaccounted for. So what you have to ask yourself is this. What would it be if I distributed the 4 to the 9? And its value would be a positive 36. And that is the value that you're going to add over to the other side. So if you take out a GCF, you have to redistribute it to whatever you get for this last term to figure out what's going to go over here because you have to keep it balanced. Now over here, we're going to take half of b. So half of -4 is -2. And then we're going to square it. -2 squared is positive 4. Notice here I didn't take anything out. So I don't have to distribute anything to that 4. It just is what it is. All right, so we have 4 on 2. Here's where I'm going to take that x squared plus 6x plus 9, which is now a perfect square trinomial, and I'm going to factor it, and it turns into x plus 3 squared. Then I'm going to take the y squared minus 4y plus 4 and turn that into a factored perfect square trinomial, so I now have y minus 2 squared. And then on the right, -36 and positive 36 cancel each other out, and we are left with 4. What's the problem? The problem is that 4 needs to be a 1. So I'm going to divide everything by 4. Well, what happens to the first one? Well, the 4's cancel. So I have x plus 3 squared. Now you can leave it like this if you want. You can put it over a 1. It doesn't matter. They both are the same. Plus y minus 2 squared over 4 equals 1. There's our equation written in standard form. So let's identify the things that we need to know. We need to start by finding the center. So h and k, the h is -3, the k is positive 2. Before I go any further, I need to find the a, the b, and the c. So let's do a little bit of work. The a squared is your larger denominator. So a squared is 4. That means a is 2. The b squared is your smaller denominator, which is 1. And if I take the square root of that, I get 1. Now I want to solve for c. So this is where I have to do a squared minus b squared, which means that c squared is 3. And when I square root both sides, that means that c is the square root of 3. So I know the a, the b, and the c. Hopefully those are getting easier. Now let's attempt to find all the stuff we need to find. So vertices, here we go. All right, vertices, we're going to use the a, and it was underneath the y. So we're going to go up and down. That means the x coordinate does not change. We're going to go up 2 and we're going to go down 2. So if we start at 2 and we go up 2, 2 plus 2 is 4. And if we start at 2 and we go down 2, 2 minus 2 is 0. So there are the coordinates for the vertices. The co-vertices come from using the letter b. B is 1, and that was underneath the x-axis. So we're going to go to the left and to the right. So we're going to take this -3, and we're going to go to the left 1 space. So -3 minus 1 is -4. Now the y value doesn't change because all we're doing is going left and right. Then I'm going to go to the right. So -3 plus 1 is -2. Again, the y value is not changing. We're just going left and right. Lastly, we're going to do the foci. Foci are going to go the same way the vertices went, and the vertices went up and down. So the foci are also going to go up and down. That means the x coordinate is not changing at all, just the y coordinate is going to change. We're going to go up and down by the square root of 3, which is not a whole number. So the way I'm going to write it is 2 plus or minus the square root of 3. And we are done with example 9. So I'm going to encourage you to try example 10 on your own. I'm going to have example 10 completed in the notes, but I would love for you to try it and then compare your answer and see how you're doing with what I have in the notes. Let me know if you guys are having questions. Now, one thing I do want to say real quick before you finish this video is, why did I say that this was so much like the circles? Well, let me, I was looking for a blank sheet of paper, which I can't find one, so let me just work right here for a second. So when we had the equation for circles yesterday, it might have looked something like this, and I'm just making this one up, okay? Let's say that it were that problem right there. Okay, so if you were working on this as it were an ellipse, according to the formula in standard form, we need this to be a 1. So we would have divided everything by that number. So we would have ended up with x minus 5 squared over 36 plus y plus 3 squared also over 36 equals 1. What do you notice about those two denominators? They're the same. Well, one of them is going to be a squared and one of them is going to be b squared, but neither of them is larger and neither of them is smaller. So this is how you know that this is a circle, if your a and your b are the same, because that means, according to this problem, that the center is at 5, -3, but for both your vertices and your co-vertices, it turns into basically being a radius. You're going to go up 6, down 6, right 6, left 6. So that's how you can tell the difference between a circle and an ellipse. In an ellipse, these numbers are going to be different, but in a circle, those denominators are going to be the same. But everything else that we've done is exactly the same. So if you were to work on one of these problems and you got that these were the same, then you have a circle. If you rewrite one of these equations and you see that those are different denominators, then that's how you know that it's an ellipse. So that's something to think about. So try example 10, then go online, check the notes, and we will talk more. I can't remember what day we have a Zoom session, and I'm not near my computer at the moment, but we'll talk more then. See you guys later.